All right, so in this lesson, we're going to take a look at performing two transformations, and those transformations are vertical stretches and vertical reflections. So I just want to start off with a little bit of a review here. This function y is equal to a of f of x is a general function that is being vertically stretched by this a value. Now that a value, we looked at two different cases so far. The first case was when a was greater than 0, and as you recall, when your a value was greater than 0, then your graph is, well, it looked a little narrow, so I'll just put that down there. Okay, also the second case was when a was greater than 0 and less than 1. Now in this situation, your graph got, well, it looked wider. Okay, so that's what we did so far when it comes to vertical stretches. Now I'm going to take you back to vertical reflections. Okay, so a function that's being vertically reflected, remember all your y values became negative. Okay, so that's what happened in a vertical reflection. All your x coordinates stayed the same, but all your y coordinates became negative. Now obviously you're not used to seeing that function in this form. You're used to seeing that negative right in front of the f of x. So y is equal to negative f of x is the general form of a function being vertically reflected. So vertical reflection. All right. Okay, so far, this is what we know about stretches and reflections. Now we're going to put these two concepts together. When you have a vertical stretch and a vertical reflection, your a value, which is the value in front, is less than 0. Okay, so to reiterate, when a is less than 0, there is a vertical stretch, okay, and there's also a vertical reflection, and I'll show you in a minute what that looks like. Okay, so we have an example here. I'm given a graph, and it looks like a radical graph, and we're gonna perform a couple of transformations. We want to sketch the graph of y is equal to negative 2 of f of x. Okay, so this is another review right here. What happened to the point xy on the graph of your original function when you applied a stretch, a vertical stretch that is? Well, when you applied a vertical stretch, all your x coordinates stayed the same, but all your y values were multiplied by whatever that a value was. Okay, so let's determine what our a value is. Okay, so if we're taking a look at our function here, remember our a value is the value that comes right in front of the function. So if we take a look at our example here, what's the number in front of the function? Well, that number is right there. So a is equal to negative 2. Okay, so you have done this already. We're just putting a negative in there. Okay, but as for transformations, you do the same procedure. And that is, well, you need to pick a few points on your graph. So let's pick 3 points. I'm going to pick this point right here, so 0, 0. Okay. Another point, 4, 2, that's pretty easy to read. And another point, 9, 3, okay? All right, so what happens to these coordinates when you apply your stretch and your reflection? Well, remember, all your x values are going to stay the same, but all your y values are going to be multiplied by that a value. And we already discussed, or we already found out that my a value is equal to negative 2. Okay, so remember, all your x coordinates are going to stay the same. So our point 0, 0 is going to become 0, comma, negative 2 times 0. Okay, let's keep going here. 4 stays the same. Okay, we're going to multiply negative 2 by positive 2. Okay, that's a point right there. Okay, and then finally we have positive 9, comma, negative 2 times 3. Okay, all right, so let's clean this up. It looks a little funny right now, so let's carry out our multiplication. So negative 2 times 0 is going to give me, well, simply a 0. Okay, oh, there you go. And negative 2 times positive 2 is going to be a negative 4. Okay, and finally negative 2 times positive 3, oh sorry, reset, that's okay, is going to be equal to negative 6. So there are my 3 new transform points. So let's go ahead and graph those. So we have 0, 0, okay, 4, negative 4, and 9 comma -6. So right there. So yeah, we want to keep the same shape. It still needs to be a radical function, but this time it's going to have a little bit of a different shape. Also, it's going to have a vertical reflection in the x-axis. So all my points are vertically reflected down, okay? And so that's my little introduction on vertical stretches and vertical reflections happening at the same time.